Good morning, my YouTube viewers. It is Crystal here, and I want to do another code review for you. I want to do the code in R and then also the code in Python, because the code in R and Python is different. And so basically that's what I'd like to do for you in this video review. But what I want to do first is I want to talk about binomial distribution, because that's what we're going to be discussing is binomial distribution. And previous videos we had discussed normal distribution, but I'll just look that up very quickly. So this is your normal distribution via Wikipedia. Let's try what defines normal distribution. Okay. A normal distribution is an arrangement of a data set in which most values cluster in the middle of the range and the rest taper off systematically towards either extreme. And so, as you can see in the diagrams here, a normal distribution takes the shape of a bell curve, and this is the formula for the normal distribution if you like mathematics. So we will be going over normal distribution in this video, although we have covered it in the past. We also will be going over binomial distribution. It says, according to Wikipedia, in probability theory and statistics, the binomial distribution with parameters N and P is the discrete probability distribution of the number of successes in a sequence of N independent experiments, each asking a yes-no question and each with its own Boolean valued outcome. Success with probability P or failure with probability 1 minus P. A single success failure experiment is also called a Bernoulli trial or Bernoulli experiment, and a sequence of outcomes is called a Bernoulli process for a single trial. N equals 1. The binomial distribution is a Bernoulli distribution. The binomial distribution is the basis of the popular binomial test of statistical significance. The binomial distribution is frequently used to model the number of successes in a sample size n drawn with replacement from a population of size n. If the sampling is carried out without replacement, the draws are not independent, and so the resulting distribution is a hypergeometric distribution, not a binomial one. However, for n much larger than n, the binomial distribution remains a good approximation and is widely used. So there you go. There's some information about the binomial distribution, and you can see a diagram here of what the binomial distribution looks like. Now what we're going to do is we're going to be covering CDF, that's cumulative distribution function in Wikipedia. So in probability theory and statistics, the cumulative distribution function of a real valued random variable x, or just distribution function of x evaluated at x, is the probability that x will take a value less than or equal to x. So that's your cumulative distribution function, which we will be covering in this code review. And then you've got something called PMF, probability mass function. It says in probability and statistics, a probability mass function is a function that gives a probability that a discrete random variable is exactly equal to some value. Sometimes it is known as a discrete density function. So there's your probability mass function. We also will be using that. And I do have to say I want to direct you to this Stack Overflow because I spent the good part of several hours, at least a couple of hours, trying to translate the code, and I couldn't translate it. And as a result of that, I had to go to Stack Overflow. And the thing is that you need to go to Stack Overflow sparingly because these people that go on to Stack Overflow are experts. And you don't want to waste their time. And you have to be careful how you word your question, because if you don't word your question just right, they will not submit it. And you also have to say what efforts that you personally have taken to solve the problem yourself. So I spent a few hours on this question, and I looked on Stack Overflow. I couldn't find anything on Stack Overflow, and I looked on SciPy.stats website. I couldn't find anything on SciPy.stats website. So I had to ask the question because, I'd been working on it for a couple of hours, and I just thought, well, if I don't solve this problem, I'm not going to be able to do this code review, and I'm not going to be able to do this blog post. So I asked the question, and I said, thank you in advance for your help, and someone gave me the answer. And then I replied, I said, "Ta very much." It gave the same return as what was in R. So they did actually give me the answer. But so I wanted to show you that I had to go to Stack Overflow to actually find the answer to this question. I had to ask an expert to solve it for me because I couldn't find it. And I'm going to tell you where I got the questions. I got the questions from this YouTube video right here. I got the questions from this YouTube video right here because I'm going over this video, and that's where I got the questions. So now that we've got a little bit of background information, what we're going to do is we're going to cover it in R, and then we're going to cover it in Python. So I got the answers in R. and then I translated them into Python because obviously this is my first proper statistics course or probabilities course that I've ever taken. So I don't know very much about probabilities. I will say probabilities is a mathematics course, and it is difficult. You have to know calculus, which I studied calculus over 40 years ago. And so since I studied calculus over 40 years ago, I need to refresh my memory if I'm going to study calculus. But the great thing about computer programming is you have to have a familiarity with advanced math techniques, but you're not really going to use them if you don't want to use them because you're just going to be coding in a programming language. So that's the great deal about it. I remember over 40 years ago when I was studying calculus, I had to do everything by hand. Okay, so we're going to do the first question is use a normal distribution to estimate the probability of more than 55 girls being born in 100 births. Assume the probability of a girl being born in an individual birth is 50%. So here's the approximate answer is 1 minus p norm, brackets 54.5, m equals 50, s equals 5. And that gives you an answer of 0.1840601. And here's your actual answer is 1 minus p binom, 55, size equals 100, probability equals 0.5, gives you a value of 0.1356265. So we're going to go over here to Python, and what I did was I translated it into Python. So we've got the same question, but we had to import scipy.stats as stats. And so the approximate answer was 1 minus stats.norm 50, by dot CDF 54.5. But your actual answer was 1 minus stats.binom CDF K equals 55, N equals P equals 0.5. So that's your actual answer. Now we're going to go back to R. After many hours of studying statistics exam, you believe you have a 90% probability of answering a given question correctly. Your test includes 50 true-false questions. Assuming your estimate is the true probability that you will answer a question correctly, use normal distribution to estimate the probability that you will miss no more than 4 questions. So the approximate answer was P norm brackets 4.5, M equals 5, brackets S equals square root of 4.5. And your actual answer is P binom brackets 4, size equals 50, probability prob equals 0.1. So in that particular one, you had an estimated answer of 0.406839 and an estimated answer of 0.4311984. And I believe that is the one that I had to go to Stack Overflow and ask for help. I will say, if you're going to use Stack Overflow and you're going to ask a question, you have to word your question very carefully, and you have to be, because you don't want to waste these people's time. These people are very good with programming, and you don't want to ask questions that are not going to help them get the answer quickly. So we've got the same questions we do from Skippy.stats import norm. And so the approximate answer was that norm.cdf brackets 4.5, 5, 4.5 to the square root of, to the power of 0.5. And that's actually square root of 4.5. Okay, and then the actual answer was stats.binom.cdf K equals 4, N equals 50, P equals 0.1. And it gives you the exact same, answers that you got in R. So now we'll go over to R. Many toothpaste commercials advertise that 3 out of 4 dentists recommend a brand of toothpaste. Use normal distribution to estimate the probability that a random survey of 400 students, exactly 300 will recommend a random survey of 400 dentists, exactly 300 will recommend brand X toothpaste. Assume the commercials are correct, and there are 75% chance that any given dentist will recommend brand X toothpaste. So the approximate answer is P norm brackets 300.5 brackets 300 square root 75 minus P norm 299.5 300 square root 75. And that gives you an answer of 0.04604031. And the actual answer is D binom 300 brackets 300, size equals 400, prob equals 0.75. And that gives you an answer of 0.04602432. So we go over here to Google Colab where we've got our Python code. And the answer was, for the approximate answer, it was norm.cdf 300.5, 300 comma 75. Well, it's actually the square root of 75, but it says to the power of 0.5 minus norm.cdf 299.5 300 and then square root of 75 again. And then the actual dentist recommendations were stats.binom PMF, K equals 300, N equals 400, P equals 0.75. So that's it. That's it for your questions where you were given the code in R, and I translated it into Python, and I made sure that all the values were exactly correct. And that just lets you know that R is a programming language, a statistical programming language made for statisticians. And Python is a general all-purpose language, but it uses libraries to do what it needs to do. And so that's it for this code review. So now you know how to code something in R, and then you know how to translate it into Python. And obviously, I have a long way to go before I know a lot about probability because it was quite difficult for me to do. And as you know, because I showed you, I had to consult Stack Overflow to find the answer to the question. So I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my code review. I look forward to making more code reviews in the future.